Imagine a world where the hum of a bustling city isn't accompanied by plumes of smoke, where the air is clean and the energy is sustainable. Picture a future where an entire city, with all its homes, businesses and infrastructure, is powered by a single, silent box. A box that holds the key to a cleaner, more efficient energy future. No smoke billowing into the atmosphere. No ash polluting our land and waterways. Just clean, reliable energy flowing seamlessly to every corner of the metropolis. Inside this unassuming box, a revolutionary process unfolds, a carefully orchestrated dance of atoms that releases immense power. It's a process that challenges conventional energy production, promising to transform our energy future, offering a pathway to a world free from the constraints of fossil fuels and the dangers of climate change. This technology holds the potential to reshape our relationship with energy. This is thorium, a silvery, abundant metal found across the globe, hidden within the Earth's crust, waiting to be unlocked. Its potential has been largely untapped until now, 3 times more common than uranium, making it a readily available resource for a sustainable energy future. This abundance is a key advantage in the quest for clean energy solutions. For years, thorium was often discarded as mining waste, an overlooked byproduct in the pursuit of other valuable elements. Its potential was not fully understood, but now it's seen as a key to clean, limitless power, a game-changer in the world's energy landscape. Scientists and innovators are recognizing its immense value. Instead of burning fuels and polluting our air with harmful emissions, contributing to climate change and respiratory illnesses, thorium lets us unlock the energy within atoms, harnessing the fundamental forces of nature to power our world. It's a shift from combustion to atomic energy. No combustion, no carbon emissions, a truly clean and sustainable energy source for generations to come. A single ton of thorium can produce as much energy as millions of tons of coal, a staggering comparison that highlights the immense potential of this resource. Imagine powering your entire town, with all its homes, schools and businesses, for an entire year. With a lump of metal you could hold in your hand, a testament to the incredible energy density of thorium. This is a fundamental shift in how we think about energy, moving away from finite resources and towards sustainable solutions. Small, decentralized energy sources, safe and sustainable, bringing power closer to the people who need it. Thorium's story is about reimagining our resources, seeing potential where others saw waste, and embracing innovation, and asking, what if we could unlock the full potential of this abundant element? Scientists and engineers are racing against the clock, driven by a shared vision of a cleaner, more sustainable future. To turn this vision into reality, pushing the boundaries of science and engineering to develop thorium-based energy solutions. They believe with ingenuity and science, with collaboration and determination, we can build a world powered by these little boxes of sunshine, providing clean and affordable energy to communities around the globe. The future of energy could be clean, abundant, and accessible to all. A world powered by innovation and sustainability. And right at our fingertips, ready to be embraced and utilized for the betterment of humanity and the planet. The question is, are we ready to embrace it? Are we ready to embrace a future powered by thorium and other innovative energy solutions? The journey starts now with each step we take towards a cleaner, more sustainable energy future. In Denmark, a team called Copenhagen Atomics is working to make the thorium dream real. Their mission? Rethink global energy with small, modular molten salt reactors. These reactors are designed to be built in factories, tested and shipped worldwide, like cars on an assembly line. Imagine a reactor inside a shipping container. Plug it in, and it quietly powers a community for years. No refueling, no on-site maintenance, just reliable, clean energy. Copenhagen Atomics is already building and testing real components from pumps to corrosion-resistant materials. Their focus is practicality, efficient, safe, and scalable solutions. This approach could revolutionize energy access, especially for remote or developing regions. It's not just theory, they're solving engineering puzzles every day. Their work shows that world-changing ideas can come from small, passionate teams. The future of energy might just be taking shape in a Danish workshop, and it could change everything. How do you unlock the potential of thorium and transform it into a reliable energy source? How do we harness the power locked within this element to fuel our future? It's all about nuclear alchemy, a process of transforming one element into another through carefully controlled nuclear reactions. This isn't magic, it's applied physics at its finest. Thorium-232, the most abundant and stable form of thorium, is not directly fissile. This means it can't split on its own to release energy in a chain reaction. To initiate the process, it needs a neutron starter, a subatomic particle that acts as a catalyst. When thorium-232 absorbs a neutron, a fascinating transformation begins. The nucleus of the thorium atom becomes unstable. The first step in this transformation is into protactinium, a short-lived radioactive element. Protactinium then decays into uranium-233, a fissile isotope of uranium. Uranium-233 is the real fuel in this process. It's the key to unlocking thorium's energy potential. When uranium-233 absorbs a neutron, it splits, releasing a tremendous amount of heat and, crucially, more neutrons. That heat is then used to generate electricity, powering our homes and industries. The process is similar to boiling water in a traditional power plant, but the heat source is nuclear fission instead of burning fossil fuels. The extra neutrons released during fission are essential because they keep the chain reaction going, sustaining the energy production. These neutrons also convert more thorium into uranium-233, effectively creating more fuel. This means the reactor breeds its own fuel as it runs, a remarkable feat of engineering. It's a self-sustaining cycle, where the reactor continuously produces its own fuel while generating power. Using liquid fuel, like in a molten salt reactor, allows for continuous operation, efficient heat transfer, and more complete use of the thorium resources. The process is elegant in its simplicity and efficiency. You add thorium, initiate the reaction with a neutron source, and the system intelligently manages itself, sustaining the chain reaction and generating power. Nearly all the thorium is used in the process, maximizing energy output and minimizing waste. This leads to significantly less nuclear waste compared to traditional uranium-based reactors. It's a recipe for clean, sustainable power, a viable alternative to fossil fuels. There's no burning involved in this process, and therefore no carbon emissions are released into the atmosphere. It's just pure, clean energy extracted from the heart of the atom. The brilliance of this technology lies in the cyclical nature of the process. It's a system where energy and fuel are created together simultaneously. This is nuclear energy done smarter, more efficiently, and more sustainably. The future of power generation could be as straightforward and elegant as following this recipe. A recipe for a cleaner, brighter future. And it all starts with thorium, an abundant element waiting to be unlocked. Forget the old image of massive, high-pressure nuclear plants, those towering structures that have defined nuclear energy for decades. We're entering a new age, one where safety and efficiency are paramount. Molten salt reactors offer a fundamentally different approach. Instead of solid fuel, they dissolve thorium fuel directly in a hot liquid salt mixture. This means no solid rods, the traditional fuel elements that require complex manufacturing and handling. And importantly, no high pressure. Unlike conventional reactors that operate under immense pressure, creating the potential for dangerous leaks or explosions, the salt acts as both fuel and coolant, simplifying the design and enhancing safety. It flows continuously through the reactor core, efficiently transferring heat to create steam, which then drives turbines to make electricity. This closed-loop system maximizes energy extraction. The entire system runs at normal pressure, significantly reducing the risk of accidents. This inherently eliminates the risk of explosive failures, a major concern with traditional nuclear technology. Furthermore, if the reactor overheats, the salt expands in volume. This expansion naturally slows the nuclear reaction, providing an automatic safety mechanism that requires no human intervention or complex computer systems, just the laws of physics at work. But the ultimate safety feature? It's a simple yet ingenious design. A frozen salt plug located at the bottom of the reactor. In the event that power fails or the reactor temperature rises beyond a safe level, the plug melts. This allows the liquid fuel to drain safely into designated tanks located below the reactor core. This action immediately stops the nuclear reaction instantly, preventing any possibility of a runaway event. No meltdown, no catastrophe. Just physics doing its job, reliably and consistently. This passive safety design means the reactor is inherently self-regulating, capable of managing itself and shutting down safely, even in the most extreme emergency scenarios. This design is therefore inherently safer, more reliable, and more resilient than traditional light water reactors. It represents a new era for nuclear energy, simple, robust, secure, and ultimately, more trustworthy. The future of energy should be safe, sustainable, and accessible to all, and that starts with designs that prioritize safety from the outset. With molten salt reactor technology, that vision can finally become a reality. That's the promise of thorium, a future powered by safe, clean, and abundant energy. Thorium reactors aren't new, they were proven in the 1960s at Oak Ridge National Laboratory. Alvin Weinberg's team ran a molten salt reactor for years, showing it was safe and effective. Weinberg believed thorium was the key to cheap, clean, and safe energy for all. But politics intervened. Uranium reactors made better bomb material, so thorium was sidelined. The world chose uranium for weapons, not for energy. Weinberg's vision was shelved, and the safer, sustainable path was forgotten. For decades, thorium was a footnote in nuclear history. But now, as we face climate change, his ideas are being rediscovered. The road not taken may be the one we need most. The story of thorium is a second chance for clean energy. Today, the world needs clean energy fast, and modular reactors are the answer. Startups like Copenhagen Atomics are mass-producing small, sealed reactors in factories. These units can be shipped anywhere. Arctic mines, desert plants, or remote villages. No on-site fuel handling, no complex construction, just plug-and-play power. After decades of use, the whole unit returns to the factory for recycling. This approach slashes costs, boosts safety, and makes nuclear energy accessible worldwide. It's the nuclear battery. Simple, secure, and scalable. The modular revolution could finally make nuclear global. Clean power anywhere, anytime. The future is arriving. One box at a time. Nuclear waste is a big worry, but thorium reactors change the game. Traditional reactors use less than 1% of their fuel, leaving behind dangerous waste for millennia. Thorium molten salt reactors use nearly all their fuel, producing 95% less waste. The leftover waste is short-lived. Safe in a few hundred years, not hundreds of thousands. Even better, these reactors can burn existing nuclear waste, turning old problems into new power. Imagine cleaning up our nuclear legacy while generating clean electricity. It's the ultimate recycling. Waste becomes watts. Thorium closes the fuel cycle, making nuclear truly sustainable. Less waste, more energy, and a cleaner future. The solution to nuclear waste may be to use it. With thorium we can turn yesterday's problem into tomorrow's power. That's real progress. Building a molten salt reactor is tough. Hot, corrosive, radioactive salt is no joke. Materials must withstand decades of heat and radiation. Special alloys like hastelloy are key. Pumps and valves must run flawlessly at 700 degrees Celsius with no leaks or failures. Every component is custom designed and rigorously tested. Chemistry control is critical. Automated sensors keep the salt stable and safe. Companies like Copenhagen Atomics are solving these challenges one breakthrough at a time. It's a dance of physics, chemistry, and engineering inside a sealed box. The leap from lab to commercial reactor takes grit and precision. Overcoming these hurdles is what will make thorium power real. The future depends on getting the details right. Even perfect reactors need regulatory approval, a slow, demanding process. Molten salt reactors are new territory for regulators used to old designs. Innovators must prove step by step that these reactors are safe and reliable. Meanwhile, a global race is on. The US, China, India, and Europe all want to lead in thorium technology. The first to commercialize thorium MSRs will shape the future of energy. The prize? Clean, abundant, safe power for the world. The challenge is huge, but so is the opportunity. Who will get there first, and will we be ready?